Okay, let's continue with the example 1. In example 1, we have a bar which is rotating about O, and there is a collar there. I'll just draw the collar here first, and then we have decided that our global coordinates, this vertical will be X, horizontal will be X, and vertical will be Y, and at the same time this bar is, the position is at 60 degrees, and this bar is rotating at 3 radian per second and accelerating at 2 radian per second square. Okay, at the same time the bar is also having a velocity of 2 meters per second along the collar. The collar is sliding this way, and it has an acceleration outwards, 3 meters per second square. In the previous example, let's call this example 1b. Let's call this example 1b. Let's continue from example 1. So in the previous section, we have decided that our coordinate system to be coincident, they share the same origin. Yeah. So in the previous system, our coordinate system was sharing the same origin. So it was basically here. This was our X and this was our Y. Now I want to ask you to think what happened if the new coordinate system, the rotating coordinate system, is on the bar. So we'll say that the rotating axis is on the bar. Okay, so they are here, and let's call that A. And C is not on the bar, though it's coincidental. C is on the collar, so let's call this C. Yeah, so A is rotating but not sliding out, but C is sliding out. Yeah, so I hope you can notice the difference. So A is on the bar, C is on the collar. So C is sliding outwards, and also at the same time A is rotating, but A is fixed to the bar. So A fixed to the bar, i.e. the bar is rotating and A is fixed to the bar. C is free to slide. C is free to slide, given. So we want to find, determine, question asks us what is the velocity of C and what is the acceleration of C. So we want to use a new coordinate system, which is here. This is our Y and this is our X. Okay, so if you can see that you can write the position vector, you can see that position vector C is equivalent to position vector C relative to A plus position vector A relative to O, and this can be written as position vector C relative to A plus position vector A. So from there you can write the velocity equation. VC is VC relative to A plus VA. In this case, we need to solve this using a rotating axis. Let's get the data out. If in terms of rotating axis, we have a long set of equation where we can say that VC equals to VA plus V relative plus omega cross R. And we have the acceleration C. There are 5 terms to it. A plus omega cross R, omega dot cross R, plus 2 omega cross V relative plus omega cross R, and there's another one which is A relative to 1, 2, 3, 4, that is A relative. Yeah, so that is the whole set of equation for the velocity. So this is for the velocity, this is for the acceleration. So what are the important data that we can collect from this scenario? So we need to find the V relative. We know that V relative is VC relative to A. That is given 2 meter per second. It moves relative to the bar 2 meter per second. 2 meter per second. And therefore we can find the A relative also. That's in terms of I, 2I. A relative is 3I. It's given. And we want to find omega dot. Omega dot is also given. It's given here, 2 radian per second square. K minus, let me rewrite that again. So omega dot equals to minus 2k radian per second square, and we have omega at 3 minus 3k radian per second. Okay, and then we move on. We want to find what else? Omega dot, omega, V relative, A relative, and then we want to find R. That is RC relative to A, and position vector C relative to A. For the time being, it is 0 because they are 0 because they are almost coincidental. So there is, assuming that there is no distance, so it's almost let's say coincidental. So collocation. The same. They share the same location. So from this equation, we can find what is V. We need to find what VA is. It's not given here what VA is. So VA is because it's rotating along the beam. A is rotating to the beam. Yeah. So the beam is rotating. The beam is rotating. So VA will follow. So VA is equals to omega OA cross position vector A relative to O, and this we know to be is 0.6I. Yeah, so this is given already. This 0.6I, if I'm not mistaken. It's 0.6I. Yes, it's 0.2 meter. So 0.2 meter. So it's 0.2I meter. And omega, do we have the data for omega? Omega is given, is minus 3k radian per second. So it's minus 3k cross 2i, 0.2i, cross 0.2i. So k cross ij, so minus 0.6j meter per second. So VA is minus 0.6j meter per second, and therefore we can write the equation for VC. Yeah, we can write the equation for VC, and the velocity of C equivalent to VA plus V relative plus omega cross R. Omega cross R, because this is 0, so we get this 0. Then VA is minus VA. We have calculated VA to be minus 0.6J, and we have calculated V relative given 2I. So that's your VC. Meter per second. That's the answer. Okay, so you can compare that with the previous example. So let's now proceed to the acceleration. What are the accelerations? So we have AC. We have got this equation for AC. What we don't have is the everything. We got everything. So we need to find AA. Yeah. So AA, again, AA is the acceleration of point A on the bar. So in this case, AA has got 2 points, which is minus omega square R plus R double dot. Yeah. So in this case, A is not so there's no component. So there's only one component, so minus omega. Omega is given by 2 minus 3 square, and r is given by 0.2 meter. So 9 times 0.2 is 1.8, and is minus I. So 9 times 0.2, 1.8 minus 1.8 minus 1.8 I meter per second square. This is V8. That's action for A. So we've got this term. R is 0, omega cross, and A relative. So in this case, if we rewrite that AC equals to AA plus omega dot cross R plus 2 omega cross V relative plus omega cross R plus A relative. Yeah. So anything that with the term R is 0, because R is 0, so we can cancel that. So we just have A. We know A is minus 1.8I, and then we have got 2 omega. Omega is 3k minus 3k cross V relative. V relative is 2I meter per second, and then we've got A relative. A relative is given 3 meter per second, 3I. Yeah, so we've got AC. So now we have got AC as section C is minus 1.8I plus 3662. So K cross I is J. K cross I is J. So minus 4 minus 12 minus 12J plus 3I. So we have here is 1.2I plus or minus 12J AC. So this is am I missing anything here? 2 omega cross V relative,